Hello, this is Patrick at OneCNC West, and what we're going to do in this training video is continue to apply toolpath to our part geometry. Now, if you'll remember in our previous videos, the parts already been transferred to the subspindle, and in the last video we applied a roughing operation. Now in this video, let's take a look at performing a profile operation. So to do this, we don't need the solid model. So I'm going to hit the letter S on the keyboard, left click the solid model, and then I can click the letter B on the keyboard, which is the shortcut for the blank command. Now the blank command can be accessed up here in the toolbar as well, and essentially the blank command just temporarily hides any selected geometry that you have. Alright, so there's the wireframe geometry. So for this, why don't we perform a profile operation along this geometry here. To do that, we'll head over to the command manager and we're going to go into our lathe toolpaths. From there, we're going to select our turn face finishing operation. And the first thing you'll note is that the cursor changes to the word start. That's OneCNC reminding us that we need to select the very start of the geometry that we'd like to profile. So I'm going to take my cursor over here to the very bottom of the chamfer. I'm going to left click, and at this point we're presented with 4 arrows. These arrows determine the side of the toolpath in relationship to the geometry as well as the direction. Well, I want to cut from right to left and I want to be on the outside, so I'm going to left click this arrow. Once I do that, the cursor changes to the word end. And again, that's just a reminder to let us know that we now have to select the end of the geometry. So I'm going to take my cursor and left click, and when we're done, we can right hand mouse click. Now, within this first dialog box, this is where we select our tool. Remember that when performing 2-axis lathe machining operations, for example, all these over here on the left, you're going to need to select a tool from the tool library. You can access the tool library in 2 ways. You can left click the tool changer button, or you can left click the tool graphic. I'm going to left click the tool changer button, and within the tool changer dialog box, you'll notice you have 2 tabs. Now the recent tab, this is going to show you the tools that have been favorited as well as the current tools. Now you can select these tools just by left clicking. You'll get a nice graphical representation over here on the right and a description down here on the left. However, for this, let's click on the library tab. Notice how all your tools are categorized into different groups. Up here we have our turn tools, and down here we have all the various tools that would be used for live tooling. In other words, things like end mills, facing tools, taps, and things like that. For this example, we're going to be selecting from the turn face category. So I'm going to left click there, and I'm going to be searching for a tool that has a 35-degree insert. So I can left click, and then if I want, I can use the arrow keys on the keyboard to move up and down until I find a tool that I like. I think that tool looks great, so with that tool selected, I'll come down here and click OK. Once I select the tool graphic appears here along with the control point and all the relevant information down here in the lower left hand corner. Now let's put this in turret position number 1. That looks good. We don't need to worry about the tool offset because this uses the same number as the station number. If you want to change that, just click and then you can type in whatever offset that you'd like. I'm going to uncheck that. We don't need to worry about coolant and work offset because the OneCNC postprocessor will take care of that for you. We have our feed rate. We can go inches per rev or inches per minute. For this example, I'm going to be using inches per rev at 5,000, and I'm also going to be using RPM. But you can also specify constant surface footage if you'd like, and specify a maximum spindle. There's also a nice calculator available to help you calculate your speeds and feeds. Very nice. Well, I'm going to undo that. Let's go back to RPM. 550 is fine for that. You also have the ability to override the postprocessor for the spindle direction. And then you also have the ability to add notes. If you click Notes, you have your Notes dialog box and you can type in any notes that you'd like. These notes will appear within the CNC program. Now, for example, if I type in finish cut, down here you'll notice this is what's going to be output in the CNC program. Notice that it's surrounded by parens or parentheses. That's to tell the control that this is definitely just a comment and to be ignored. Now, if you don't want the automatic parentheses, just uncheck automatic comments, and then this now will be considered actual CNC code. But for comments, typically you're going to want to have that checked. Let's click OK to that, and then click Next. For the clearance style, 95% of the time, you don't need to change this. This is how the tool is going to exit after it's performed the machining operation. The only time that you'd ever want to change this is when you're performing more complicated types of toolpath. But typically, you can leave this default set to no move. Let's click Next on that. All right, now we have two options up here. We have Select Boundary and Select Contour. Now, we're going to be using Select Contour, and that's because we want to apply the toolpath to the contour that we selected earlier. However, if we had drawn an additional rectangle, we can use this option called Select Boundary, and the toolpath will still recognize the geometry that we selected, but it will contain that toolpath within that rectangle that we had created. We haven't done that. Let's just keep it simple and go with Select Contour. Now let's take a look at Z clearance and X clearance. These are very important values, as this is where the tool is going to move to at the very beginning of the machining operation, and then at the end of the machining operation, the tool is also going to move to that location. So here's how the Z and X clearance values are applied. So with a Z clearance of 200 thousandths, remember how we had selected our profile here at the very base of the chamfer. Well, if we take 200 thousandths and add it to that, the start point's going to be right about here, 200 thousandths away in Z. We take a look at the X clearance. OneCNC looks at the geometry that we selected for the profile operation, and it looks at the very end X value, and it adds 200 thousandths to that. So the Z clearance and X clearance location is going to be 200 thousandths away in X, 200 thousandths away in Z, so it's going to be right about here, right about where my cursor is. So simply put, the Z clearance and X clearance is where the tool is going to move to before and after the machining operation. Another thing to take a look at is this option called Approach Clearance. This is set to 600 thousandths. Let me explain what this does. In fact, let's set this back to 0 for just a second. What that means is that the tool is going to wrap it here, away in Z 200 thousandths, away in X 200 thousandths, and then it's going to wrap it all the way down in X until it becomes right at the same location as the start position for the chamfer. But if I put in 600 thousandths here, which is probably too big of an amount, here's what's going to happen. The tool is still going to wrap it away from the part, Z 200 thousandths, X 200 thousandths, and then it's going to wrap it down, but instead of wrapping all the way down to the same X value as the bottom of the chamfer, the tool is going to wrap it down and stay 600 thousandths away, and then it's going to feed down 600 thousandths and then approach and start the profile. All right, so think of the approach distance as just the feed distance as the tool is, in this example, as the tool is moving down along the X-axis. All right, let's click Next on that. All right, so here's our main dialog box for the turn face finish machining operation. For cut direction, for this example, we want to leave it to longitudinal. For the cut direction, we want to leave this set to auto, and notice how the arrow is moving from right to left. Remember how when we originally selected our geometry, we selected it from right to left? Well, that's exactly what automatic is doing. It's looking at that selection direction. We're not going to take a look at Smart Finish right now. We'll take a look at that in an upcoming video, so we're going to leave that unchecked. And number of cuts to finish, you have different options here. We're going to take it in just one pass. Over here for nose compensation, you have different values. Automatic default, that means that the toolpath will recognize the tool nose radius. And none means that instead of the tool nose radius, OneCNC will recognize the theoretical control point and drive that on the geometry. So remember, automatic is going to recognize tool nose radius. Typically, that's what you want. And in addition to that, if you'd like to use cutter comp G41 or G42, you can use these options down here. We're going to leave it set to automatic default. Now for finish allowances, that's how much material do we want to leave in X and Z. Well, since this is a finish pass, we're going to leave these set to 0. And then for your groove control, this is how you control whether or not the tool is going to enter into a groove. We don't have any grooves in the geometry that we have here, so this really doesn't apply. But if we did have grooves and we had cut grooves on, OneCNC would take the tool and it would cut down into the groove, recognizing the angle of the tool insert, not to violate the geometry, but just to go in as far as it can. But with cut grooves set to off, notice how OneCNC will take the tool path and completely ignore the grooves. Okay, and again, for this example, it really doesn't matter. All right, let's click next on that. So now we have our cut to end and cut to start parameters. Let's reset this back to what it would look like by default. Let's undo that. So let's begin by taking a look at cut to end. With this unchecked, notice how OneCNC takes the control point, the theoretical control point of the insert, and it's going to use that and stop at the very end of the geometry. And that's exactly what we have here. But notice if I check this, instead of using the control point, OneCNC is going to use the tangency of the tool nose radius, and it's going to take that all the way to the end of the geometry. So think of this as tangent to the tool nose radius, and this is using control point. Same with cut from start. This is how our profile is going to start. Here with this unchecked, again it's using the control point, but if I check this, OneCNC will use the tangency of that insert at the very beginning of the geometry. Now if you want to extend that amount, you certainly can. If you check this, you could then type in a value, for example 50 thousandths. That means that the tangency of the insert's going to start 50 thousandths away from the beginning of the geometry that we selected. Same with cut to end. We can check this, and if I type in 50 thousandths, the toolpath is going to go 50 thousandths past. Very, very simple, and it's very, very versatile as well. All right, let's click Finish and let OneCNC generate the toolpath. And just as instructed, you can see that OneCNC, before the toolpath, has moved the tool to X 200 thousandths, Z 200 thousandths, moved down along the X-axis, started 50 thousandths before the geometry, profiled all the way around, gone 50 thousandths past, and then returned to the X 200 thousandths, Z 200 thousandths position. All right, that's it for this training video. Thank you so much for watching, and I look forward to seeing you in the next video.